Welcome to the GeoDict Online Seminar, Automation of Parameter Studies using GeoPy. The goal is that after attending this seminar, that you will be able to record and playback macros with GeoDict in order to automate common and repetitive tasks. Also, you will learn how to add variables to macros, to optimize and analyze materials while running parameter studies. Finally, you will see how to access any GeoDict result from a Python macro. In detail, we will start in part 1 with macro recording and parameter studies. There, I will introduce you to GeoDict commands. I will explain to you what are commands and how do they work. Afterwards, we together will record and play back GeoDict commands in form of macros and have a look at the structure of a GeoPy macro. We will introduce variables in the macro and use VariMacro for a parameter study. In the second part, Python language basics as text output, variables, and string operations will be explained. And we will go on with part 3, where we will record a simulation and access the results from a macro. Finally, I will give you an outlook on some advanced topics. So let's get started. In GeoDict, almost every action is a command. For example, if you load or save a structure file, run a simulation, or render images or movies, everything is a command and can be saved to a macro. Each command then has a name and a set of parameters. So, for example, the result file name or some boundary condition, solid volume percentage, and many more. For this, the actions in the user interface execute corresponding commands. These commands then can be recorded in a macro. And this macro consists of a list of commands with the parameters. And if the macro is played back, then the same commands are run again. Additionally, macros can have variables which can also be set in the user interface. And of course, we want to see these macros and commands. Therefore, as a first example, we create a macro from a structure generation. And for this workshop, we will generate a fiber structure. I will go on performing the steps live in GeoDict. So let's together move to GeoDict. First, I select a suitable project folder. For this, click on File, choose Project Folder, select Project Folder, and navigate to an empty folder for the seminar. Now, GeoDict saves all following results in this folder. There are two possibilities to save a macro. One way would be to first start macro recording and then execute the GeoDict commands that you want to record, and then end macro recording. The second possibility is to press Run and then save the commands afterwards. Both ways have their advantages, but we choose the second possibility in this workshop, which has the advantage that you do not need to know beforehand what you want to record. We can simply select the right commands afterwards in the session macro dialog. So now, as we want to create a fiber structure, we have to choose the FiberGeo module. For this, we click on Model and then FiberGeo. Now, FiberGeo should be displayed in the Module section here in the bottom left of GeoDict. And from the pull-down menu, Create Fibers should be selected. Next, to change some settings for the fiber structure generation, click Edit. We keep the default result file name FiberGeoGDR. But we will change the domain size to 200 times 200 times 100 voxels. We keep a voxel length of 1 micrometer, and here in the bottom right, have a look at the stopping criterions. Here a solid volume percentage of 10% is chosen. The solid volume percentage is a geometric measure, meaning that 10% of the volume is solid material, so that the fiber generator will place fibers in the structure until the solid volume percentage of 10% is reached, which also results in 90% porosity. The material for pore space is air, as you can see here above. So then move to the Fiber Options tab, and we see that two fiber types are generated. They are both infinite circular fibers and consist of glass. Set one diameter to 12 microns and the other to 6 micron diameter. Since we want to vary the volume percentage ratio later, set the percentage to volume %. Click OK to close the dialog and click Generate. The results are shown in the result viewer. We can see that our stopping criterion was reached nearly perfectly. Close the result viewer again. And now the generated fiber structure is shown at a 2D view in the visualization area. Let's visualize it in 3D. For this, we click here on the toolbar on the 3D button. And then you can turn around the structure by clicking on it and holding the left mouse button. So now we can see it from all sides. To record the generation of a fiber structure, now we click on Macro and then we select Session Macro. For the current session, GeoDict automatically records all commands from the user interface, and they are listed in the upper panel here of the Session Macro dialog. In the beginning, we find some commands from starting GeoDict, for example, the GeoDict expert settings and the preferences. And afterwards, we find the commands we executed together. The fiberGeoCreate command, which generated the fiber structure. And then the corresponding result file was opened in the result viewer and closed again. We will need the fiberGeoCreate command, and here all parameters of generating a fiber structure are saved. To save the command, we highlight it by clicking on it. And then we click on the single arrow here. And then the command will appear here in the bottom panel. Everything in this panel will be saved in the macro when we click Save. So let's click Save. Now we have to choose a name. For example, we can call it Workshop 1. And as we see here, it is saved to the project folder we selected earlier. Before we play back the macro, we close the Session Macro dialog and then discard the structure, as otherwise we would not see any effects of the macro as it creates the same fiber structure again, of course. So therefore, we click File and then Discard Structure and Volume fields. And now the visualization area is empty again. So we want to play back the macro to create the fiber structure again. Click on Macro, execute macro script, and now the macro execution control opens. Here on the left we have the built-in default folders. The last folder is the current project folder. We can just unfold it, and here we find the macro Workshop 1 we saved before. So if you highlight it here, on the right, we can see all the commands that can be found in this macro. This is a helpful preview panel. In this case, of course, we only see the fiberGeoCreate command, as it was the only recorded command. To play back the macro, we simply click Run here on the right side of the dialog, and then the file fiberGeoGDR already exists in our project folder, as we created it earlier, so we can simply click Overwrite here, as we only repeat the same fiber structure generation. Now we see the same structure is generated again. The next thing we will do is having a look at the structure of a Python macro. For this, go back to the macro execution control, highlight Workshop 1, and click Edit. The macro then is opened in the default text editor, which is Notepad++. Of course, it can be changed anytime to a desired text editor. Now we see here that the macro file starts with a prologue, which has 3 parts. First, there is the header, which contains information about the used GeoDict release, which is of course 2025. The revision, the build date of the revision, the creation time of the macro, who recorded the macro, and on which platform it was created. Afterwards, we have a description, and by default it gives only some information that is also contained in the header, but this description is displayed in the macro execution control. So if you go to the macro execution control, here in the description panel, the same description we find in the macro is displayed here. But we can change it, of course, to anything we want. Usually it is a good place to describe what the macro does. This way, if you recorded and edited the macro with a good description, you can give it to your colleagues and they can use it without ever looking into the Python code. And here after the description, we find the variables block. This section creates a custom user interface, accessible in the macro execution control, as we will see soon. By default, it is always a commented out example of the solid volume percentage, because the solid volume percentage is a part of many structure generators in GeoDict. This variables block then consists of a name, which is used inside the macro, the label, which will be seen in the user interface, a type, so for example it could be double, which would be a floating point number, or an integer, or a string, even a table or combo box are possible. After the type follows the unit, which also will be displayed in the user interface, a tooltip, which can be seen when hovering over the label in the user interface, a built-in default value, and a check. So the solid volume percentage, for example, should be at least 0 and maximum 100, which makes sense when it has to be given in %. And then it follows a commented out explanation of the variable syntax. For example, you find here a list of the possible types, and for all variable types, you can also find a description and an example in the GeoPy scripting user guide, which opens if you click Help in the macro execution control. After the variables description, you will find some examples of variable usage and some frequently used Python syntax. So comments can also be helpful to make a script more readable. They are always introduced by a hash in Python, so everything which comes after the hash in the same line is ignored when executing the macro. The macro is always executed from top to bottom. And now, here starts the block with the recorded commands. Our workshop macro only contains the commands to create a fiber structure. The prologue before is always a part of a recorded macro in GeoDict, even if no commands were recorded at all. But the content of the command section depends on what was recorded from GeoDict. For each GeoDict command, the parameters are saved in the Python dictionary, which is assigned to a variable, in this case createArgs1, and the dictionary always consists of key-value pairs. We see the keys on the left and the values on the right. These keys correspond to the respective parameters in the FiberGeo options dialog, as for example the number of voxels here in X, Y and Z direction, which define the domain size. And here we have the solid volume percentage and the result file name. In Notepad++, we can collapse the sections by clicking the minus symbol here. This can give you a good overview when many commands are recorded, so you can see more commands at once. In the first line of the dictionary, now follows the actual command, the gd-run-cmd, which stands for run command. This command needs 3 input parameters. First, the name of the command, here the FiberGeo create command. Then the parameters dictionary, which is defined above. And then the GeoDict release. This third parameter could also just be 2025 as a string. But in recorded commands, the release is always read from the header, as values of Python dictionaries can be accessed by entering the corresponding key, here in square brackets, after the dictionary name. So we can compare this with the header dictionary above. And here the first key is the release, and this release has the value 2025. And this then is the input for the gd-run command. So we now have a macro that always generates the same structure. This is only useful to save parameters. What if we want to vary some aspect of the geometrical generation? Or generate several variants automatically? We need to vary some parameter of the structure. For this, we can use a parametric macro and vary the parameters from the user interface. Variables in the variables block in a GeoPy macro then can be assigned a value by the user directly from the user interface. This allows to write a parametric macro and provide it to colleagues who can use it without ever touching the Python code. We save a copy of the Python file so we do not lose the original. Therefore, we click on File, Save As, and change it to workshop2.py. And make sure that it is saved to your project folder again. In Notepad++, this is automatically saved as a Python file if you use the ending py. In some other text editors, it can be necessary to choose the right file type from the pull-down menu. So then click Save. And now in the Variables section, we uncomment all the green lines by removing the hash. And now the variable for solid volume percentage would be accessible in the macro execution control. But we want to change the ratio between thick and thin fibers. For this, we change the variable name to GD_fraction thick fibers. Then, for the label, we will use fraction of thick fibers. The type and unit can be kept as they are, and the tooltip can either be deleted or changed to fraction of thick fibers. Set the built-in default to 50 and keep the check as it is. For a percentage value, it makes sense to check if it is between 0 and 100. We now want to give this variable impact in our fiber generation. For this, we have to remember the name we gave to the variable, GD_fraction thick fibers. And this name, by the way, can be chosen as desired. You only in the macro need to use the same name as you chose in the variable section. For readability of the macro, however, it is recommended to use a name that describes the variable's usage. The GD prefix we also only use for readability, as this way we can recognize which variable was set from the user interface and which is introduced within the macro. Back to giving the variable some impact. For this, scroll down to the Create Args1 dictionary, and there in the parameters, we look for the line with the key generator1, which describes the thick fiber type, which we can verify when looking at the diameter value here. We want to change the probability. There we replace the number 0.5 by the variable name, which is GD_fraction thick fibers. And to transform the percentage number to the format GeoDict expects, we add a division by 100. Next, we look for the generator2 parameters for the thin fiber type. For the value, we enter 1 minus parenthesis GD_fraction thick fibers divided by 100. When we are finished with our changes, we click on Save. This way, we use a floating point variable with the name GD_fraction thick fibers in the parameters for fiber GeoCreate, allowing us to change this value from the macro execution control. Now, go back to the GeoDict user interface, and here, next to the visualization area, we hover over the statistics, and we can see the volume percentages for all the materials. For material ID 1 and 2, the percentage is close to 5%, which is a fiber ratio of 50% thick fibers and 50% thin fibers. We will change that now. We open the macro execution control again. If you did not close it in between, you have to click Refresh to make Workshop 2 appear. As you can see, while Workshop 1 is still highlighted, the Parameters button on the right is grayed out. But as soon as we highlight Workshop 2, this button becomes available as we introduced a variable. It allows us to define a value and run the macro using the given value. Click Parameters and a new dialog box appears. Here we see the label fraction of thick fibers, the unit percent, and the built-in default value 50 that we defined in the variables section. Also, when we hover the mouse over the label, we can see the tooltip. To create less thick and more thin fibers, we just change the value to 25. This value then will be used for the variable GD_fraction thick fibers. So now we click OK and then run. Now a new structure is generated, so change the name by adding 25 and clicking Rename to save the new structure under a new name. It is possible to automate this renaming task, but we will come to that in the second part of the workshop. Now we can see that fewer thick fibers are generated. We can also verify the fiber fractions again by looking here to the statistics. Our first structure had equal amounts of volume percentage for both fiber types, and the new one now has only about 2.5% thick fibers, and the rest thin fibers. The next step would be a parameter study. Now we can see the benefits of adding a parameter to the macro earlier. We can vary its value automatically. Back to the macro execution control again. Then here above the command preview, select vary instead of fixed. And if we then click on parameters, we can enter a value list instead of only one value. For example, enter 10, 40, 70 for the fraction of thick fibers. The macro then will be executed 3 times, once for each value. We click OK and run. Now we have to change the result name manually, but as promised already, we will automate that soon. So here, add 10 for the first one. Then the second one would be 40. And the last one would be 70. So back to the GeoDict visualization area. Here we can see the last generated structure with 70% thick fiber fraction. Again, we can validate the fiber type fractions in the statistics here. And if you want to see the results from the whole parameter study, we can open the project folder by clicking File, choose Project Folder, and Open Project Folder. Now the project folder is opened, and here we can find all the result files and result folders, and of course the 2 macros we generated in this workshop. As always in GeoDict, the results consist of a result file containing some information about the simulation and a result folder, which in this case only contains the generated fiber structure. Here in the slides, we can also see an overview of the 3 generated structures. Here we can see how the fiber ratio changes. This is the end of part 1. Now we have seen how to record macros and insert variables to them for parameter studies. We will start part 2 with Python language basics. First of all, what exactly is GeoPy? We have seen and run Python macros and even added a variable. But apparently, we did not really mention GeoPy. GeoPy is an interpreter of Python 3.11, so that any regular Python script should run in GeoDict. However, GeoPy gives access to GeoDict-specific functions. They are called the GeoPy Application Program Interface, short API. And an API is a set of commands, functions, protocols, and objects that programmers can use to create software or interact with an external system. The GeoDict API commands all can be recognized by the prefix GD. In fact, we have already seen a GeoDict-specific function. The GD-run command that is used to run the commands which are saved from the user interface. We used it to generate a fiber structure. To start with Python, we suggest to record a Python macro in GeoDict, as we have done together here in this workshop, and then we can use variables and value macro for parameter studies. But now in the following, we show you some useful Python language basics. They will help you to make parametric macros even more useful. I will type them together with you in the editor. Open the editor again and open a new file with File, New. We will save this file as output.py. The first Python basic function I will show you is text output. Text output can be very useful for debugging. Imagine, for example, a longer Python script does not produce the expected results. Then it would be good to know where exactly the error happens. By printing the intermediate results, this can be found out. In this workshop, we will present two possibilities for this purpose. The first one is a GeoDict-specific function. It starts with a GG and then MSG box, which stands for message box. And then inside of round braces, we enter the output. In this case, it will be a string. Strings are always marked with quotation marks, either single quotes or double quotes. Only make sure to use the same quote possibility for starting and ending the string. And then inside the quotes, we enter the string hello world. This function will open a message dialog displaying hello world and an OK button, which is used to close the dialog. You can also output integers like 42. So we can output most basic Python values like, for example, strings, integers, and floating points. The second possibility for text output I will show you is a Python command which is called print. The content again must be defined within the braces, and this content will be printed to the console of GeoDict. Here again we will print hello world, and again make sure that you have quotation marks in the front and in the end. Click Save and open the macro execution control. Just click Refresh again, and then the new file output.py appears. Highlight it, and as it has no variable section, the parameters button is grayed out. And because it contains Python commands beyond the normal GeoDict commands, no preview is displayed. Click on Run, and the first message box appears. Click inside the box to stop the countdown, because at the end of the countdown the box will be closed automatically. Here we see our string hello world. Clicking OK closes the message and lets the second message appear, which is 42. Click OK again. Whereas the message boxes appear automatically, the output from the print command can be found in the console of GeoDict. Therefore, below the visualization area, unfold the console by clicking on Console, and here you can see the two messages from the message box, which is always in these 3 lines here. And in the last line, before the finished macro execution line, you find the output from the print command. If you want to have text output, but do not want to interrupt the macro execution with message dialogs, the print command would be preferable. The next thing I will show you is how variables not defined in the variable section work in Python. Therefore, we open a new file again in the text editor, File, New, and this time we will save it as variables.py. So any type of data can be stored into a variable. We had the example earlier of defining a parameter called GD fraction thick fibers, and all the parameters declared like this automatically appear as a Python variable in your macro. They will have the value given in the user interface. But variables can also be defined wherever it is needed in the script. We only need a name and some value. Of course, then they do not appear in the user interface. But that is not necessary for every variable. We also had the example of a variable of this type before. And we have a look at the Python dictionary, where the parameters for the fiber creation are defined. This dictionary was also assigned to a variable, and this was called createargs1. This was needed to execute the actual command for the fiber structure generation. So a variable is defined in the moment it is first assigned. For example, if we call a variable a and then assign the value 42 with the equal sign, then from now on a is 42. We can also show it with a message box, and then we only have to write gd.msg box, round braces, and inside we only need to write the name of the variable. Then in the message dialog, 42 will be displayed. Also arithmetic works as you would expect. So, for example, if we call the next variable b and assign the value a plus 1, then now b will be 43. So we can also show the value of b in a message box. GD MSG box b. Also, the value of a variable can be replaced by a new value. If you assign a new value to a, then from now on, a will be another value. But for the assigning process, you can also use the old a. For example, a times 2. Then here on the right side, a is still the 42, but from now on, a will be 84. We will also output this in the message box. GD MSG box, and inside the braces a. The last variable will be a string. Let's call it s. Then we assign our hello world string to it. And of course, we will also output this, GD MSG box s. Click Save and open the macro execution control again. Click Refresh and highlight variables py. It has again no preview and no parameters, like the output py. So let's click Run, and right away, here we see our first message box, displaying 42, which was the variable a. Just click OK, and then the next message box shows 43, which is b, and then here we have our new a, which is 84, and finally the hello world string from our string variable. The last Python basic that we will discuss in an extra file are string operations. Again, back in the text editor, open a new file. Then we will save this file as strings.py. First of all, different strings can be concatenated by simply adding them. So let's introduce variable s, and then we will start with the string hello, and then by using a plus, we concatenate it to another string, which will be space world. Then we will output it again with the GD MSG box command. And this will lead to our previous string example, hello world. The next thing about strings I will show you is adding variable values into a string. Therefore, first define some integer and float variables. For example, a is 42 again, b is 3.456, and c is 2.65, e minus 14. Now we define the string s1, and we will start with the string format f, because this allows us to input and format variable values in curly brackets into the string. So after starting with the f in front of the string, we write, for example, value of a is curly bracket, and in the curly brackets add a, comma, value of b is, again curly brackets, b, and value of c is c, of course again curly brackets. And when we output this with the GDMSG box, the following text will appear. Value of a is 42, value of B is 3.456, and value of C is 2.65 e minus 14. And we can also control how many decimal places are shown in a string. Call the new string S2, and remember starting with an F in front, and then inside the quotation marks write B is, then in curly brackets B, colon, dot, to F. This means the value of B with only 2 decimal places, which is 3.46. For C, it would display 0.00, as the E notation means 2.65 times 10 to the power of minus 14, which is a very small number, with 2 as the 14th decimal place. Thus, we will use another formatting for C. So go on with and C is, curly brackets, C, colon, dot, 1e. And this will lead to C as it is, but with only 1 decimal place, meaning 2.7 e minus 14. So also output S2 with the GD MSG box, S2. Then click Save and open the macro execution control again. Click Refresh, highlight StringsPy, click Run, and now we see the concatenated string, hello world, and just click OK, and then we see S1, value of A is 42, value of B is 3.456, and value of C is 2.65 e minus 14. Click OK again. And then the S2, B is 3.46 and C is 2.7 e minus 14. Click OK. And now using this knowledge about strings, we want to take care of the issue that in our parameter study, all structures were saved under the same name, FiberGeoGDR. We had to rename it for each generation, which is very inefficient. Our goal is to make the parameter value part of the result file name. So move back to our workshop 2, and then we look into the parameter dictionary GeoDict1 for the key result file name. Here we have the result file name FiberGeoGDR right at the top of the parameter dictionary, of course as a string. To achieve our goal, we start with an F in front of our string, as we did before in the strings py. And now, as we vary the fraction of thick fibers in our parameter study, we want to add the value of the variable GD fraction thick fibers in the result file name. For this, before the file ending, add underscore and in curly brackets GD fraction thick fibers. The underscore simply puts more focus on the variable value optically. Thus, the string varies with the values for GD fraction thick fibers. Click on Save and open the macro execution control again. And highlight workshop 2. Click on parameters and make sure that you have still the values 10, 40, 70. Click OK and run. Now we do not have to rename anything. Look at the project folder and see the new generated files with the underscore notation. The 3 new result files and result folders automatically containing the fraction of thick fibers value. I will now shortly show how to add a second variable and different ways to vary the variables. You do not need to follow this. The goal would be to use a vary macro to create structures not only with different fiber type ratios, but also with varying total solid volume percentage. For this, I saved workshop 2 as workshop 3. In the variable section, I copied the complete dictionary for variable 1 to paste it below. Now I changed name, label, tooltip and built a default value for my new variable. Again, I had to give the variable some impact. For this, in the GeoDict1 dictionary for solid volume percentage, I replaced the value 10 by the variable name GDSVP. Of course, now I directly change our result file name to make also the second variable a part of the result file name. Here we now see our second variable, the solid volume percentage. And now for the fraction of thick fibers, enter again 10, 40, 70, and for the solid volume percentage I enter 5, 15, 25. When running the parameter study, the macro will be executed once for all parameter combinations from the two lists. Here on this workshop slide, you can see an image for all 9 combinations. As we had 3 values for both variables, the result is 3 times 3, so 9 different fiber structures. And here the SVP grows from the left to right and the fraction of thick fibers increases from top to bottom. Also, the number of fibers increases from left to right to reach the given solid volume percentage and decreases from top to bottom because less thick fibers are needed to reach the same solid volume percentage. Back to the macro execution control, we have here the variation pull-down menus for both variables here on the right. With this, we can couple certain variables that have the same number of values given for these two variables. Here, for example, we see that we can couple a solid volume percentage with the fraction of thick fibers, or the other way around, which will make no difference. Just select solid volume percentage for fraction of thick fibers. Then, the macro will be executed for the value pairs. On this slide, the result is visualized. In contrast to the previous macro execution, now only 3 of 9 parameter combinations were generated, which we can see here in the diagonal. This is because only the value pairs were used instead of the cross product. This is the end of part 2. We have seen some language basics as 2 types of text output, and we have seen variables and string operations, and also we added a second variable to our macro. Finally, we did parameter studies with different parameter combinations. Let's start with the last part. Now you can follow me again and we will run a simulation to access the results. And later I show you how to save nice images from a macro. A simulation would be the next step after generating structures, so we choose a flow simulation. Select Predict, FlowDict. Here from the pull-down menu, choose the first one, the Stokes-Brinkmann equation, and click Run. The results are shown in the result viewer, and we later will be interested in the permeability value here. But for the moment, we just close it. Now open the session macro dialog again. And here we can also see that the macro execution and vary Python macro are GeoDict commands that can be recorded, so that you can also run a macro from another macro. But we only want to get the FlowDict solve Stokes command. However, we will not save it in a new macro with this command, but instead we will attach this command to our already existing workshop macro. Because analyses like the flow simulation always happen on the currently loaded structure, and we want to run it on the different fiber structures. Therefore, just select it and click Copy to Clipboard. This will only copy the selected commands with the parameters, so we can just take this command and append it to our existing structure generation macro. First, we save it under a new name with File, Save As. We will call it workshop4.py because workshop3.py was my demonstration macro for the 2 variables. Then here in the macro, scroll right at the end of the macro, and by right-click and clicking Paste, paste the FlowDict command. Then we see here the FlowDict command, and above, the FlowDict parameters dictionary. The first line of this dictionary is the result file name. And of course we want to edit this name again, so that the variable values are part of it. Write the f in front of the string and append underscore GD fraction thick fibers and curly brackets. Click Save and go back to the macro execution control. Click Refresh, highlight Workshop 4, and now we can see that the preview changed to also containing the FlowDict command. Click on Parameters And for the fraction of thick fibers, again enter 10, 40, 70. Click OK and run. Now 3 fiber structures are generated and the permeability is computed for each of them. Of course, we already generated these 3 fiber structures, so we simply click override for all of them. So then override the second one and permeability is solved. Override the third one and also permeability is solved. For the third one, with the 70% thick fibers and 30% thin fibers, if we now look again in our project folder, we can see additionally to the fiber structure results, the 3 Stokes result files and result folders. Now we want to access the simulation results, as each structure generation or simulation produces a single GDR file containing all result values. For this, we move back to the main GeoDict user interface. Close the session macro dialog and open one of the FlowDict result files. By clicking on File, open Results, and then browsing for the results file. Here all the results from the flow simulation are stored. We can see a nice report of the results, and here, right at the top, we find the permeability tensor. The first 2 columns are empty, as flow was only simulated in Z direction. Of course, we could change that either in the FlowDict user interface or in the parameters dictionary in our macro, if you wanted. For now, we are only interested in the permeability value in the bottom right. So in the third column and the third row, which would be position 3, 3, then we move to the map tab here, which is a subtab of the results. And we find a list of key value pairs. These keys we need to access the respective values. We want to have the permeability 3.3 value here. So we have to remember this key and that it is in the results map. With this knowledge, we go back to our workshop 4 macro and save it under a new name again. File, save as, and now workshop 5.py. And then in the first line of our macro, add a new line, import string map. This imports the Python module string map, which will allow us to access string map files. As GeoDict result files basically are string maps, this is exactly what we need to access our flow simulation results. Now scroll to the end of the macro, right below the FlowDict command. And here, while scrolling down, we can see the computation directions we mentioned earlier. Here, true means flow will be computed in this direction, and false means it is not computed. So if we wanted to, we could also select the other 2 computation directions by changing false to true. But we just continue scrolling down until after the FlowDict command. First, we let the runCMD function return the result file name and store it into a variable. Just call it GDR name, for example. Then we will store the GDR file content in a variable, which we call GDR. And here we right away need the module string map. And there we need the command pass GDR. And in round braces, we must enter the result file name as a string. And for this, we use our variable GDR name to be sure to have the right result file name. We only want to have one value in the result file, and that is the permeability we have seen before. It will be a string. So we call the variable we will use for this value perm string. Accessing the values in the string map works similar to accessing values in a Python dictionary. As we have seen in the gdrun command, with square brackets. And inside these brackets we have to enter the right key. In this case we want a value from the result map, so we write result map. Then a colon, because we now are in the result map. And there we need the key permeability 33. Here we always first need the right map. First it's the result map and then the right key inside this map that we found in the result map. As we would like to have this value as a floating point number instead of a string, we simply transform it. The new variable we will call perm, and then we will use the Python command float, and in the parentheses we will enter perm string. Then we will use the API function again, GeoDict box, to see the obtained permeability after each simulation. We will enter a string and start with an f in front to format our result values. In the quotation marks we enter for curly brackets the diffraction thick fibers %, thick fibers permeability is curly brackets and inside right perm :.2e. Then let's add the unit, which is square meters. As the permeability value is very small, we format with the E syntax we saw earlier in the strings example. We will only show 2 decimal places in the message dialog. Finally, save the macro again. Then move to the macro execution control, click refresh, then highlight the workshop5.py, and now we see that the preview is gone. That is because we added Python syntax, which is not part of the GeoDict commands, and thus it is no simple macro anymore. Click parameters and enter again 10, 40, 70 for the fraction of thick fibers. Click OK and run. And now we have to override not only the fiber structures, but also the corresponding floating results. Then our first message dialog appears. For 10% thick fibers, permeability is 2.12 E-11. Click OK. And override the second fiber structure and the second stocks result. For 40% thick fibers, permeability is 2.95 E-11. Then override the last fiber structure and the last stocks result. And the result for 70% thick fibers and 30% thin fibers is a permeability of 3.84 E-11 square meters. In this way, any value from the result file can be accessed. You only need to know the right key and the right map, which you can find in the result file. We can not only access the result map, but also the input map, the log map, and the post map. Now in the last step, I will shortly demonstrate to you how to visualize our results and save nice images from our workshop macro. For this, I load one of the floating result files again and move to the Flow Visualization tab. Here click Load, and in the opening dialog click OK. After loading the 3D result field, I changed the visualization settings as camera angle, colors, streamlines, smooth surface, as desired. When I am happy with the visualization, I can save an image with this button from the toolbar. I chose one of the presets and saved it under Streamline's PNG. Then I can copy the needed commands from the session macro. First, we need the command to load the volume field to be able to visualize the streamlines. Then we also need the setViewStatus command, because all visualization settings are saved in this command. And finally, the third command we need is of course the Save 3D Image command. Press and hold Ctrl while selecting the needed commands with left mouse click. I used copy to clipboard and appended them to my workshop macro, which I called workshop6.py. The file name has to be changed in 2 places, in the Save 3D Image Parameters dictionary and in the Load Volume Field Parameters dictionary. I extended the Workshop 3 macro to visualize the flow field considering 2 variables. In this slide here you can see the streamline visualization for all 9 combinations I showed earlier with the 2 variables. Observe how the velocity is much slower for higher solid volume percentages and much faster for a larger fraction of thick fibers. Of course, you can reproduce every visualization by recording it to a Python macro, just like that. After showing you how to access simulation results and save images from Python macros, in the end, I want to tease some advanced topics, and we will start with a PowerPoint report example. GeoDict comes with a simple application user interface to generate PowerPoint reports. This is very useful, for example, if similar parameter studies are done often. Then a Python macro can generate a unified report of the results to analyze them and show them in a nice way. This slide and the following slide are generated by a Python macro following a parameter study. For this, we used many more combinations of solid volume percentage and fraction of thick fibers in our workshop macro. The macro read the permeability values for all the combinations using the string map module and created a table using the PowerPoint API. We can see that the influence of the solid volume percentage is larger than the influence of the thick fiber fraction. This is even more obvious when visualizing these values in a color graph created with the Python module matplotlib. Here we can see that the permeability decreases significantly for the increasing solid volume percentage and increases for increasing fraction of thick fibers. How to generate PowerPoint reports you can learn from the GeoPy scripting user guide. Finally, we briefly touch onto some other advanced possibilities. First of all, you can also execute macros directly from the command line, including setting variable values, which is a powerful method to integrate GeoDict in your custom simulation and analysis pipelines. Furthermore, we have a set of GeoDict application program interface functions, where we already have seen the GD1 command for the fiber structure generation and the flow-dict simulation, and the GD MSG box. These two could belong to the most important of these, but we also provide functions, for example, to directly access the voxel structure or simulation result fields, and for writing import geo wall filters for micro-CT images. We can find an overview of the API functions in the macro execution control. Here you see a nice overview of all the function names and which arguments are needed, and what is the return value, and a short description. Additionally, the help button will lead to the GeoPy scripting user guide. And it will not only explain the macro menu with all options, but also contains many examples on how to record macros, adding variables, how the different variable types work, and even all of the API functions have an example. You can also find a description of our simplified Weber API for the PowerPoint report generation. Then we also ship a set of popular open source Python libraries, which are installed into the Python interpreter within GeoDict. This includes fast MATLAB-style numerics with the module NumPy that could, for example, be applied to volume fields as the flow field we have seen before. Then we have the powerful plotting library matplotlib, which was used for the image we have seen before. It allows to plot the results in a user-defined style. Of course, the Excel file generator XLSXwriter to create Excel files from a Python macro. The built-in Python interface GeoPy enables the automation of any kind of workflow. This significantly increases the productivity in the usage of GeoDict. Macros created in GeoDict can be adjusted by using the entire range of Python. Any kind of GeoDict data can be accessed and processed from Python scripts. Finally, your results can be exported directly into PowerPoint presentations. This enables, for example, the execution and individual presentation of parameter studies. I really hope now that this will ultimately help to increase your productivity when working with GeoDict. In the last slide here, the link here on the bottom leads to a great official Python tutorial to learn more about scripting with Python. Thank you for your attention.